Welcome to Learn All Online Educational Channel. This is Shariful Ashiyam, your instructor for the Nature of Probability in Statistics, Chapter 1, Section Measurement Scales. In today's lesson, we will discuss about how the data are measured in different levels and different scales. In previous session, we explained the variables and we classified them into quantitative variables and qualitative variables. In addition, variables can be classified by how they are categorized, counted, or measured. For example, data can be organized into specific categories such as area of residence like rural, suburban, or urban. Consider the next example. Data values can be ranked such as first place, second place, and etc. Or they could be ranked as agree, strongly agree, disagree, or no idea. Consider another example. Sometimes data values are obtained from measurement such as IQ, height, or temperature. So the given example shows the classification of data from the perspective of how they are categorized, counted, or measured, and that is called measurement scales. Nominal level, ordinal level, interval level, and ratio level. First, nominal level. It classifies data into mutually exclusive, non-overlapping, existing categories in which no order or ranking can be imposed on the data. For example, subjects which are taught like English, history, psychology, mathematics, and etc. Second, gender. Gender is another example of nominal level data. Classifying residents according to zip code is also an example of the nominal level of measurement. Political party like Democrats, Republicans, Independent, and etc. is also another example of nominal level of data. Religion like Christianity, Judaism, Islam, and etc. and marital status like single, married, divorced, widowed, and separated. These are also examples of nominal level of data. Second, we have ordinal level of measurement. The ordinal level of measurement classifies data into categories that can be ranked. However, precise differences between the ranked do not exist. For example, from a student's evaluation, guest speaker might be ranked as superior, average, or poor. Other examples of ordinal data are letters grade like A, B, C, D, and F. 3. Interval level of measurement. The interval level of measurement ranks data, and precise differences between units of measurement do exist. However, there is no meaningful zero. For example, many standardized psychological tests yield values measured on an interval scale. IQ is an example of such a variable. There is a meaningful difference of 1 point between an IQ of 109 and an IQ of 110. Temperature is another example of interval measurement, since there is a meaningful difference of 1 degree Fahrenheit between each unit, such as 72 degree and 73 degree Fahrenheit. Ratio level of measurement. The ratio level of measurement poses all the characteristics of interval measurement, and there exists a true zero. In addition, true ratios exist when the same variable is measured on two different members of the population. Examples of ratio scales are those used to measure height, weight, area, and number of phone calls received. Ratio scales have differences between units like 1 inch, 1 pound, and etc., and a true zero. In addition, the ratio scale contains a true ratio between values. For example, if one person can lift 200 pounds, another can lift 100 pounds, then the ratio between them is 2 to 1. Table 1 2 examples of measurement scales. Nominal level data, and the examples are zip code, gender like male and female, eye color like blue, brown, green, and hazel, like political affiliations, religious affiliation, major field of study like mathematics, computer science, economics, and etc., and nationality. In ordinal level data, we have grades like grade A, grade B, grade C, grade D, and grade F. We have the judging like first place, second place, third place, etc. We have rating scales like poor, good, excellent, and for example, we have ranking of tennis players. We have the interval level of data. We have the SAT score, or we have the SAT score, IQ or intelligence quotient, temperature. We have the ratio level data. We have the height, weight, time, salary, and age. Applying the concept. In here, guys, we have a scenario, we have a case, and we have some questions. We will going to answer them after reading this passage. So this passage is about the safe travel. So read the following information about the transportation industry and answer the questions. So transportation safety. The chart shows the number of job-related injuries for each of the transportation industries for 1998. So we have the industries and we have the number of job injuries. Industries like railroad, we have intercity bus, we have subway, we have trucking, we have airlines. So, and we have the corresponding number of job injuries for railroad, which is 4,520 job-related injuries, and the highest number of job-related injuries belongs to the airlines, which is 9,950. So, question number 1. What are the variables under the study? The variables are industry and the number of job-related injuries. Question number 2. Categorize each variable as quantitative or qualitative. So the type of industry is a qualitative variable, while the number of job-related injuries are qualitative variables. Number 3. Categorize each quantitative variable as discrete or continuous. So the number of job-related injuries is discrete. Question number 4. Identify the level of measurement for each variable. Type of industry is nominal and the number of job-related injuries is ratio. Question number 5. The railroad is shown as the safest transportation industry. Does that mean railroads have fewer accidents than the other industries? Explain. The railroads do show fewer job-related injuries. However, there may be other things to consider. For example, railroads employ fewer people than other transportation industry. Question number 6. What factors other than safety influence a person's choice of transportation? So the answer will differ from different perspectives. So one possible answer is that the railroads have the fewest job-related injuries, while the airline industry has the most job-related injuries. Question number 7. From the information given, comment the relationship between the variables. The relationship between the variables, it It means what are the relationship between the industries and as well as the number of job related injuries. And here it says the railroad has the fewest job related injuries, where the airline industry has the highest number of job related injuries. So thanks for watching. Please subscribe and share with your friends.